This is a lecture on 5-3, binomial distribution. Before we define a binomial distribution, we need to talk about binomial experiment. A binomial experiment is a probability experiment that satisfies the following four requirements. There must be a fixed number of trials. So we cannot talk about infinite things, we cannot talk about theoretical things. It's something like you try to hit a basket of basketball and you're trying to do this 10 times. So this is the fixed number of trials, the 10. Each trial can have only two outcomes, or outcomes can be reduced to two outcomes. These outcomes can be concluded as either success or failure. So in mathematics, we define success as something that you are looking for. So let's say I'm interested in somebody losing, so that's going to be my probability of success. So be careful. Sometimes the wording can get you. But the idea of a binomial experiment is that each trial can only have two outcomes. You will either win or lose. You will either make the basket or you don't. You hit or miss. You're either male or female. So only two outcomes. Number 3, the outcomes of each trial must be independent of one another. So going back to that, making a shot into a basket, because this is my favorite example. The way you throw it the first time has nothing to do with the way you throw it the next time. It's a completely independent event. They're not connected in any other way except it's the one person who's making a shot. The probability of success must remain the same for each trial. So this probability of success is judged some other way. For example, we're looking at the basketball player and we know he has 80% chance of making the basket. So thus 80% chance will follow him through all of those 10 trials of trying to make a basket. So these are my four requirements. The hardest thing for the hardest thing for a binomial experiment is to be able to recognize it. So it should always be in the back of your mind because this is not going to be visible that we're talking about a binomial experiment. But if the four items are satisfied, you are able to use a binomial distribution, binomial formula, and binomial probability, and all of the formulas that we're going to talk about 5-3. So what is a binomial distribution? My next vocabulary word. It's a collection of outcomes of a binomial experiment with corresponding probabilities. So just the reason binomial distribution is in chapter 5 is because it is a discrete probability distribution. You cannot make 2.5 shots. You will either make 2 out of those 10 in a basket or 3 out of those 10 in a basket. It is not possible to be anything between 2 and 3. So binomial distribution is a discrete distribution, and it can be displayed in similar ways that we discussed in 5-1 and 5-2. So you can either write it down in the table where you have all of the corresponding x's, all of the x's, and all of their corresponding probabilities written in the table. Or you can take this table and try to do a histogram where you represent each of the x's, just a class. So you have a visual display. So those are the, so this is the probability, this is the binomial distribution. You can either look at it as a table or as a histogram. The next thing that I have on my notes is notation. Notation is important. Please make sure to recognize those because the letters are going to be used in the formulas where you should be able to see them. We're going to label a P and a Q. Notice all of these are lowercase letters. The book uses X as a capital one, so it really doesn't matter as far as the X, but all of the other ones, they have to be lowercase letters. So P stands for probability of success. Usually this number is given, or it's very simple to figure out. Q is the probability of failure, meaning 1 minus P. The P and the Q are complements of each other. The N will be the number of trials. So that's that, you're trying to make 10 baskets. So that's your N. The X is the number of successes in N trials. So let's say you make 10, you're trying to make 10 baskets, and then you succeed only twice. So the X is 2. So that means that you made 2 out of those 10 trials. Now my next set of formulas, these formulas will be given to you on the test, maybe with the rest of the formulas that are given in the previous videos. And this one is programmed into your calculator. So a binomial distribution is very widely spread and is used. So it is programmed into your TI-80 form. And this will be the last video of 5-3 after I do examples. This formula describes the probability of making exactly 2 shots out of 10 when you're trying to make that basket. The X is getting exactly the number of successes. So if I'm interested in making exactly 2 out of those 10 baskets, the 2 is going to be my X, and the N is the number of trials. So that's going to be my 10. The P and the Q should be given to you. So if I have a basketball player that has like 80% chance of making a basket, this will be a 0.8, this will be a 0.2. And notice that this n factorial, n minus x factorial, these are your choosing numbers. So this is why it's under probability. This is why all of this is programmed. The connection between choosing numbers and the binomial probability formula is work of mathematics of 17th, 18th century. And we did find that there is a relationship between a binomial probability formula and choosing numbers. And just like, and this formula is programmed into your calculator. I will show you how to use this on the last videos. And the following formulas are the mean, variance, and standard deviation. Because just like all the other distributions, you should be able to find a central tendency, and you should be able to find the spread. In my next video, we will look at examples out of section 5-3.